What kind of mathematician are you? And before you say, I'm not a mathematician, in some sense, we all are. Every time you estimate whether you have enough time, compare two prices, look for a pattern, calculate a probability, or try to solve a problem logically, you're using some of the same habits mathematics is built on. Of course, mathematics itself is supposed to be objective. A proof is either correct or it isn't. 2 plus 2 doesn't change depending on your personality. But the way we think does. Give the exact same problem to 10 people, and you might get 10 completely different ways of approaching it. And the strange thing is, this isn't new. Look through the history of mathematics, and some of its greatest breakthroughs and some of its strangest moments reveal very different ways of thinking. So, today we're going to meet 10 types of mathematicians. Keep one question in mind as we go. Which one are you? And quick heads up. If this is your first time on By Intent, hit subscribe. Every week, we take one thing you thought was completely obvious and show you it never was. The first type happily skips 10 steps of a calculation, writes obvious at the bottom of the proof, and flatly refuses to explain them again, even under torture, even at 2 a.m. the night before an exam. The greatest representative of this type in history is Pierre de Fermat. In the 17th century, he scribbles in the margin of a book that he's found a beautiful proof of a theorem, but that the margin is too narrow to contain it. That one sentence would go on to obsess mathematicians worldwide for 358 years. It wasn't until 1994 that Andrew Wiles finally proved this famous Fermat's last theorem, with a proof over 100 pages long, relying on mathematical tools that didn't even exist in Fermat's time. Either Fermat had a brilliant proof lost forever, or he simply thought he had one and was wrong. Either way, obvious, really? You ask the second type what 2 plus 2 equals. He starts by redefining the empty set, then the Peano axioms, then the construction of the natural numbers, and arrives at 4 about 20 minutes later. This type genuinely exists on a collective scale. In the 1930s, a group of French mathematicians working under the pseudonym Nicolas Bourbaki set out to rebuild the entirety of mathematics from its strictest logical foundations in a massive series of books. The result is absolutely rigorous, and so austere that generations of students have feared it ever since, nicknaming it, with a touch of affectionate irony, the Bible. The third type draws a diagram for absolutely everything. A simple addition, diagram, a walk to buy bread, diagram complete with vectors. That reflex, though, has produced some of the most elegant revolutions in the history of mathematics. When René Descartes, in the 17th century, has the idea of overlaying numbers onto a simple grid of perpendicular lines, what we now call a Cartesian coordinate system, he single-handedly fuses geometry and algebra into one discipline for the first time. Without that simple draw-everything reflex, no function graphs, no GPS maps, no data visualizations. The fourth type cannot say a single sentence without fully formalizing it. Let x be a strictly positive real number, just to tell you it's nice weather outside today. It's a caricature, of course, but it comes from a very real historical concern. In the 19th century, mathematicians realized that centuries of calculus had been resting on dangerously fuzzy foundations, with definitions more intuitive than rigorous. Mathematicians like Augustin Cauchy and Karl Weierstrass step in to precisely formalize what a limit, a continuity, a derivative actually mean, with definitions so strict and so precise that they're still used word for word in every math class in the world today. The fifth type tests 3 cases, it works every time, and he proudly concludes, it always works. Flatly refuses to check a 4th case. That's exactly the trap anyone would have fallen into with Paulia's conjecture in number theory. The idea seemed true for absolutely every number you could test by hand, true for hundreds, thousands, millions of tested numbers. Except it eventually turns out to be false, but only starting around the number 906 million. A counterexample patiently hiding, completely out of reach of any manual calculation, just waiting to ruin generations of "it always works." The sixth type tells you, "I just know it's true," without ever being able to explain why. And the most frustrating part is, he's consistently right. This profile has a name in history. Srinivasa Ramanujan, a self-taught Indian mathematician from the early 20th century, would send his British colleagues extraordinarily complex mathematical formulas without a single formal proof attached. He simply said, a Hindu goddess revealed them to him in dreams. Generations of mathematicians have since spent decades rigorously proving formulas that Ramanujan had just known to be true, without ever proving them himself. The seventh type rejects a perfectly correct proof, simply because it isn't elegant enough for his taste. That reflex sparked a real controversy in 1976, when the four-color theorem, the idea that you can always color any map using only 4 colors so that no 2 neighboring regions share the same color, was proven for the very first time, but only with the help of a computer, which had to individually check thousands of specific cases. Many mathematicians refused for years to consider this a real proof, not because it was wrong, but because no human could verify it entirely by hand, or admire it as a whole. The eighth type couldn't care less about the abstract beauty of a theorem. His only question: what's the point if it doesn't help calculate a bridge? And yet, history sometimes loves to turn that contempt right back around. Non-Euclidean geometry, developed in the 19th century purely out of abstract curiosity, with no practical application whatsoever in sight, would become, a century later, one of the central mathematical tools behind Einstein's general relativity, the theory that explains gravity itself. Today's "what's the point of that?" sometimes becomes tomorrow's indispensable foundation. Conversely, the ninth type looks down on anything remotely practical. That's not even real math anymore, that's just engineering. Total historical irony. Number theory, long considered the purest and most useless branch of mathematics, by the own admission of some of its greatest champions, who were actually proud of its uselessness, became, just a few decades later, the absolute foundation of modern cryptography. Every time you make a secure payment online today, you're directly using the useless mathematics this ninth type looked down on so much. And finally, the 10th type, still, endlessly, trying to trisect an angle with only a compass and straight edge, 2,500 years after the ancient Greek mathematicians themselves started doubting it was possible, and nearly 200 years after it was formally proven, in 1837, to be mathematically impossible. And yet, even today, passionate amateurs keep sending every single year supposed solutions to this problem to university math departments around the world. A phenomenon so common and so well documented that it even has its own informal nickname among professional mathematicians: angle trisectors. So, honestly, which one of the 10 are you? Tell us in the comments. If this made you smile, or if you recognized yourself a little too precisely in one of these 10 profiles, hit like, subscribe for the next one, and tell us, what other type of scientist should we explore next? Physicists, coders, biologists? Remember, all of this happened by intent.